Wow, my computer's lagging. Alright, let's X Chrome. Oh, this lag's terrible. Am I out of RAM or something? Let's go. Good morning. Oh, come on. Let's go, let's go. Quitting Chrome is taking all my computer's energy. Yeah, 7 in the morning. You gotta wake up early, boys. Math waits for nobody. So, I had to come back on because I have a few things to complain about. Okay, first off, MetaMath doesn't have separate files. It doesn't have like I'll show you Coq. So in theories, this is Coq, right? Like, look, notice how they have, directories and separate files and like normal stuff that you think would be good. MetaMath has one file. It's called set.mm, and it's all of math in one file. Now you think, okay, one file. Maybe they're using some tool to edit this, but I really don't think so because these are comments. I mean, maybe it's done by something automatic, but what kind of a comment is MathBox for Jim Kingdon, right? What kind of a comment is that? Oh, this is the end of Norm McGill's MathBox. And then these are the names. All the theorems have these incomprehensible names. Bro, hierarchy. Why don't you have a class? This is terrible. So, you read MetaMath. I read this book yesterday, and you read it, and you're like, wow, the introduction's really good. Okay, the program, all right, the program seems kind of okay. Your first formal system, okay, this is all good. And then you look at MetaMath syntax, and you're like, what the hell is this shit? So there's a great formalizing 100 theorems. This is a great. Mostly, I'm not even sure how long this stream is gonna be. I'm really just upset. Yesterday, I found MetaMath. I thought it was I found the future. I found something great, and I made the mistake yesterday of not reading any MetaMath code because holy shit, it's unreadable. Here's the proof in Isabelle that the square root of 2 is irrational, right? Okay, so here we go. From the fact that p is prime, assume that 1 is less than p. All right, so that's true. Assume the square root of p is rational. Then we'll obtain 2 natural numbers, blah, 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 blah. This is the proof in MetaMath. What the fuck is this shit? Oh, let me just use the Brecky Q. Oh, yeah, well, this theorem's referenced by all of these. This is unreadable garbage. Yeah! So much for MetaMath being the future. And You see? Ugh. There's an old Google story about RAM. No, you know what? No. You get a timeout. Don't ask about the fucking keyboard. All right. Look. This is a Google story about RAM. There's two kinds of RAM in the world. There's cheap RAM and there's expensive RAM. And cheap RAM uses cheap chips on cheap boards. And expensive RAM uses expensive chips on expensive boards. But this isn't what you want. You want boards that are really well designed because it's a non-recurring expense. And then for the recurring expense, you want, cheap chips, right? I forget how the story relates to this, but I do know that this shit makes no sense at all, and this shit looks reasonable. So I remember kind of how the story relates. I really like MetaMath's focus on simplicity. I like that they have one rule because, Coq already has don't get me started yesterday where we were with you have a type, you have a prop, and you have a set, and these are all fundamental constructs of the language. And this is before we're even coding any tactics. This is still while we're just trying to code Galena or whatever their specification language is, right? And that's just their typing system, right? So MetaMath has a very simple typing system. It's just substitution, and they explain it to you, and it's phenomenal. But you think they could have layered a bunch of things on top of that to make it more usable, at least. What? There's one global namespace for all of MetaMath. There's one global namespace, and it has variables like com13 and simpr and n0. Why would you do this? You know what? You know how you get coprime in Isabelle? Coprime. I bet here it's called CP0.21D. No, we're not going to do anything productive, and mostly I just want to complain about MetaMath because what the fuck is this shit? And this is what I wanted. But maybe Isabelle has a simple core. Yeah, I've seen Lean. Mostly I wanted to go on stream to complain because I just couldn't believe that this is what MetaMath is. I was so excited. And then okay, so you see this MetaMath 0. This new paper that comes out, people were hyped on it. And I'm not sure, is this a different language? I think this is trying to fix that. Well, this is a whole lot more. You see, this is a whole lot more readable. I mean, at least it has different things. When you go to set, I don't know what this is. Oh, good. Look, guys, they have HD maps. Oh, they have HD maps. All the self-driving car companies who want HD maps to try looking in MetaMath's 33 megabyte text file. And I'm not sure if I don't get it because clearly tons of work has been put into this, and I believe that these people are a lot smarter than me. So but why? Why is it in one file? Look, they have a lot of people doing this. To prevent GitHub merge conflicts, please change the above date if there are no other pull requests in the queue. I got a little scared when I started reading this. Like, the first chapter of this book is so good, and then you get to, you'll also need a text editor capable of editing plain ASCII text in order to prepare your input files. Like, they're talking about editing these things with Microsoft Word. You use what at work? Oh no, I just Googled the word this. So, yeah. Modeling weak memory? I don't even know what weak memory is. No, we're not getting distracted again today. We're here to complain about MetaMath. I just, this is more readable now, but like still, like they can't get out of this style. You know, the car code is actually really nice. Okay, don't prove me wrong. Let's bring up. Here's like their implementation of Peano arithmetic. Oh, okay. Like, wow, this looks like very sensible. Okay, 1 has a successor, 2 successor, add 0 and L. Well, the L's look surprisingly like 1s. But like still, wow. Like, if I read this, this looks like a programming language that people have seen before. Here we go, you know, I don't know what revert means, but like, all right, we're going to do induction on n to prove that when you subtract from a successor, you can like factor out the subtraction. And like this is supposed to be the same thing. These two files are supposed to be the same thing. This one uses like words. Wait. Yo. Time out. We don't talk about the keyboard here, man. We don't talk about the keyboard, okay? Wait, why am I in Sublime? No Sublime. I want VS Code. All right, you want me to put something in the description? I don't know, where's the description? Oh, the go live notification. It's the only place to put it in the title. Oh, here we go. Can I edit this? Edit pens. Here we go. Here's my Twitch. Edit pens. Ask about keyboard equals timeout. There we go. I put the keyboard in the description. We're not proving true it was false anymore. Today is just for complaining about MetaMath. Because you know what? That might be today's stream. That might be today's stream. I succeeded because I couldn't. I had to complain to somebody about the file that's 500,000 lines long with code that looks like this. I had to complete. No. Now you guys are talking about Ethereum and bullshit. No. That's today's stream. MetaMath is not the second coming that I thought it was. It's actually just like this. And I'm sad and. Paranoia Scary for you, California. This is a good rhyme scheme. All right, but do you guys do Headspace? This is not an ad, I promise. I actually pay for Headspace. I take your subscription money and I pay for Headspace. So we're gonna meditate because we need to calm down. I was really hyped up this morning. I wanted somebody to complain to about MetaMath, and I'm glad that you're all here for me. But anybody who asks about keyboards, about Ethereum, complains about my social skills, the band hammer is swinging this morning. And it's a chill band hammer, but it's swinging. All right. Over the last few sessions, we've talked about common obstacles. Restlessness, sleepiness, agitation. All of those feelings are perfectly normal. Just let the thoughts come and go.
So welcome back to the Headspace journey, and today's 17. Now, many people say that when they're learning to train the mind in this way, they often experience a little bit of boredom. And if you think about it, that's not that surprising, given how stimulating everyday life is. So when we pause and we sit without any distraction at all, then because we're not used to it, it can feel quite boring. But that's really usually it's because we haven't developed sufficient curiosity in the exercise. There's perhaps a feeling of wanting to be somewhere else or of wanting to be doing something else. And so we're not really present with what's happening. There's an idea of the possibility of doing something else instead. So the more we can be present and genuinely curious in what's happening in each and every moment, the less likely we are to experience boredom. So just take a moment or two to get comfortable, eyes open, and when you're ready, some deep breaths in through the nose and out through the mouth. And with the next exhalation, just closing the eyelids, allowing the breath to return to its natural rhythm. As you just settle in for those different physical sensations. And just taking the time to notice any sounds. As you notice the sounds, also noticing any resistance to any of those sounds. And then just bringing the attention back to the body. Just starting to notice how the body's feeling. And again, being curious, genuinely curious in the present moment. Starting at the top of the head, gently scanning down towards the toes. Not assuming anything is the same as yesterday or the day before, but really looking at each part of the body afresh and noticing those areas of tension and areas of comfort, of ease. At the same time, just starting to notice any particularly obvious mood that might be around right now. As you continue to scan down towards the toes. And having acknowledged that, as always, just taking a moment. Be clear about your motivation, your intention. Be clear about how beneficial this is not only for yourself, but also to those around you as well. And now just coming back to the breath. So just resting the mind on that rising and falling sensation. And just becoming a little bit more familiar with that feeling. And then when you're ready, just starting to count the breath as they pass. Again, applying a genuine sense of curiosity, not assuming that each breath is the same as the next, but watching each and every one afresh. Remember, the minute you realize the mind has wandered off, it's got caught up in any particularly strong feeling or pattern of thought, in that moment, letting go of whatever that is and just bringing the attention back to the breath again. And then just letting go of any focus at all, without any effort, any sense of control, just letting the mind do whatever it wants to do. And then just bringing the attention back to the body again. Feeling the weight of the body, physical contact between the body and the chair or the floor. Noticing any sounds. Just bringing the mind back into the physical senses as you just gently open the eyes again. And as you just sit back for a moment, it's worth just reflecting on this idea of boredom and curiosity with this exercise. So if we're only interested in getting a result in the exercise, if we're not really interested in the journey and the process of it, then we're never really going to find the answer that we're looking for, because the journey and the process, that is the answer. It's learning to observe with a soft focus, with a curious mind, with an open mind, that we start to really get an understanding of the dynamics of mind, that we start to experience a greater sense of calm and clarity in everyday life. I'll see you back here tomorrow for day 18 of the Headspace journey.
That was nice, guys. And now we're going to be open to the metamath way of doing things. We're gonna try our best to understand why decisions were made, and assume that just like Chesterton's fence, until you understand why the fence was built, you absolutely don't have permission to tear it down. This is from Gödel Bach. So let's see if we can understand it. First, let's see if we can use the program. Of course, it doesn't have tab complete. All right, well. I've played some text-based adventure games before. They remind me of this very much. this must mean define constant. Oh, these are constants as well. Turnstile is a symbol and WFF is a symbol. All right, next we'll declare some variables. I'm not sure what types said variables have. And then we're going to try to write a verifier for this. WX $F with X. Oh yes, of course, yes. Theory, we shall assume that these variables, okay. Maybe we're going to have to understand the language first. Oh yes, the basic key. All right, so I went in a bit of a rabbit hole last night and I watched some Terry Davis videos. And the Temple OS is actually pretty cool. But there's an insistence almost on a like, the language looks based off of a love for the Commodore 64. And I mean, that's great if you're building a language for fun or for God or whatever, but why would you do this? Why don't you use words? This, you know what this reminds me of? Okay, no. We meditated, we're calm, but XKCG password, correct horse battery stable, you know? You guys know this XKCG? Like, there's a joke that, like, you know, people use passwords like this, and it's bad, but this is a much better password. So, like, this stuff looks like the Troubadour and3 of passwords, where I'd rather a programming language look like Python or correct horse battery stable. But you know, there's probably we're gonna learn this language anyway, because if you can learn brainfuck, you can learn anything. Terry Davis radicalized me. Oh, he's an interesting guy. Yeah. I hate when nah, never mind. Okay, that's the empty sequence for some reason. Basic, and these are auxiliary. Start of included. This almost looks like, I mean, they have a grammar in here for it. They have the EBNF here. So if you're going to have a grammar, why would you do this? Okay. Constant symbol declaration, variable symbol declaration, disjoint variable restriction, variable type floating hypothesis, logical essential hypothesis, axiomatic assertion, provable assertion, start of proof, end of the above statement types, start of block, end of block. So more difficult to remember at first, the brevity allows them to blend in with the mathematics being described. Their brevity encourages brevity in the function names too. You could have written function names that were this long, and you're like, most time spent programming isn't spent typing out words. Now, it's true that if you're in an extremely small scope, variable names aren't that important. You can always use like I as a counter or anything. You don't have to describe what I counts. But whenever you're in a global scope, the name becomes more and more important. And considering all of metamath seems to be a global scope, okay. So these are label tokens. Each E, F, A, and P must have a label declared for it. No other statement types can have label. Every label must be unique. Okay, this seems sensible. So WX seems to be a variable type hypothesis that X is well formed. Okay, that kind of makes sense. I mean, I would name it something like X is well formed, but that's just me. WX works as well. Define MIU. So, by the way, for those who aren't familiar, there's a decent Wikipedia page on this, the MIU system. So it's just basically like these rules, and there's a question of like, can MU exist? Assume that the variables, now these are axioms. So the empty sequence is well formed. M after any well formed this is sensible. This basically just talks about strings can basically be, you start with the empty, and then you build it up. I mean, I'm a little confused here what the scoping of X is. Do all these X's refer to the same thing? It's just like some kind of global variable. Assert the axiom, MI, then assert the rules. Okay, this looks complicated now. So that's the axiom, and now assert the rules. Now, this is a block, which I don't exactly understand why you need blocks. But we'll just assume that you need blocks. Okay, E. What's an E? An E is a logical, essential hypothesis. Given any theorem ending with I, it remains a theorem after U is added to it. Wait, but that's not. Is that a rule? Oh, here. Add a U to any string ending in I. So that's rule number 1. We have an E and an A. So an E is like given. And the E means like given or something. That's a rule. And close the block. Given any theorem starting with M, it remains a theorem if you go like that. And then that's actually there. So for this one, let's see if we can make it up. We have something that's an X, and we have 3 I's, and we have a Y, and you can replace it with a U. I can remove any W's. Does that match? Yeah, that matches. Cool. Now we'll prove the theorem. So it's a theorem. It's a provable assertion. That am I, you, this. The really cool thing I don't know how to prove. Okay, so let's say. What? Okay, so we start out with, they could have at least this. Common syntax, this. Let's see if what I wrote parses so far. Seems right. I don't understand all this initial stuff, right? Why do I need all that? Don't I want to just start with the axiom and apply the rules? What is all this crap? This should be the whole proof. Let's pretend it is and see what it complains about. So if we start out with the axiom, which is mi, we apply rule 2 twice, which is going to turn it into m with 4 i's. Then we apply rule 1, which adds a u to the end. Then we apply rule 3, which makes it into 2 u's. Where this is kind of ambiguous, because if I understand correctly, I have after this I should have m I u. This is just the ugliest. Is that not the ugliest comment syntax you've ever seen? It's asymmetric. And then, okay, so we have triple I. Rule 2 and rule 4. I actually did rule 4 wrong. There's a bug there. Yeah, we're drinking whiskey, you guys. We're drinking tea. We're drinking the same tea we drink every stream. Oh. Too bad. I've never experienced the joys of iMovie. Oh, look. They have all the answers right here. That's easy. Yeah, so, I mean, this one... This is ambiguous, actually. Proof step 2. Statement II requires 2 hypotheses, but the RPN stack contains only 1 entry. I mean, I guess, okay, do I have to tell it what I'm making? Can I nest comments, or is that not supported? You absolutely cannot nest comments. That would be way too much to ask. Expected slash or nothing. Is this a mistake? Or am I just not understanding? Oh, there's like ways to do proper editing in that. Alright. Statement II requires 2 hypotheses, but we only have 1 hypothesis. Why does it require 2 hypotheses? I have mx, and I want to make mxx. Yeah, it's reverse Polish notation. I saw... Okay, let's look up what that is. I've seen this before. It's like when you just write, it's like 3, 4 plus, right? Yeah, it's postfix. I get that it's postfix. I guess what I don't understand is why this consumes two things. I mean, do I have to write its output? All right, let's start with a simpler theorem. Well, that they write out the word theorem for some reason. We gotta write that out. Let's just prove MII. We should be able to prove that by just applying axiom rule to QED. Okay, it requires two hypotheses. So now, is the hypothesis that it requires this? Cannot be unified. We'll work our way up to that theorem. Oh no, I gotta call it theorem 1 print. Okay, so I guess I'm just not really sure what it consumes. Maybe it just consumes I? Well, okay, wait. Let's just assume that it consumes the variable. So the variable is just I. Yeah, that's right. Still wrong, though. The hypotheses of statements II at proof step 6 cannot be unified. Hypothesis 1. I mean, doesn't that seem like if it is reverse Polish notation that that's correct? It doesn't have to do with my enters, right? Wait, how'd that get back? I just want that. Oh, I did it on the wrong line. Wow, that was really stupid of me. Okay, cool. Yeah, no, that makes sense. All right, so now we have MII as a theorem. I mean, this is really stupid. All right, now, yeah. So we apply it. That's going to prove MII. Perfect. And now we want to prove. Well, if I want to use rule 1, we ask the question is what is x? So x in this case is MI. If we have 4 i's, we want to stick a u after it, then it's MII is the hypothesis, and this will just be I underscore, and that's right. All right, cool. And now we want to substitute the u's. So if we want to substitute the u, okay, now this consumes two things. We have to put in x and y, and if it's reverse Polish, I assume we do x first. Let me finish this exercise, and then we'll go into more judgment of this language. Again, I wonder if this is how it's really used, because this is okay. So if we have, I assume that's x, and then we want to put in y as well. So y in this case is going to be IU. verified and I messed up. Is it just backwards? Perfect. Okay, and now we want to get away with, we want to double this. So if we're doubling, we just put in what x is, which is m, which is u, I, u. And now we can use rule 2 to get m, I, u, I, u, u. Check that. It's correct. And now, in order to finally yield the thing we want, we just want to make those two u's disappear. So we have x first, which is going to be m, u, I, which is x, and then y is just I, u. And then, yeah, this, get rid of those, get rid of those two u's. Okay. Oh, yay, look, we did it. Guys, so this consumes this, this consumes this, this consumes this, this consumes this, this consumes this. This makes no sense. Why would anybody do things like this? Okay, but let's see if we can write. Let's see if we can write a MetaMath verifier. It does seem like an extremely simple language to verify. Is much easier to write MetaMath. Alright. Should I even bother writing a grammar for this? Yeah, I probably should. Looks simple. Good exercise. So this is a complicated grammar for, let's just write out mm.g. Oh, I'm already thinking like MetaMath. Is that the right? A database is comprised of a bunch of outermost scope statements. An outermost scope statement is, oh, file inclusion command. Oh, great. We don't need that for now. Why would you ever include files when you can put everything in one really large file? Isn't that the MetaMath way? All right, an outermost scope statement can be a constant statement or a statement. This is a constant statement. So we're going to constant plus. It's a constant statement. Statement is a block or a variable statement. I don't know why this couldn't just be hypothesis statement. It helps me learn to type it out. I'm aware that I can copy and paste. Okay. A block. You can have 0 statements in a block. That's good to know. What do I call? Did I call it verify as well? I probably did. I called it go.py. Very good naming. We're gonna parse miu.mm. What? It doesn't let me use. I guess constants have to be declared at the beginning, and that's what that's saying. Do we use any disjoint statements? Yeah, whatever, we'll put them in. Hypotheses statement is either a floating statement. I'm going back there because I want to see this. I don't think we use any floating statements, but we definitely use essential statements. Why do I use Chrome? Because Chrome had 0 days? You're this close to being banned. You're this close to being fucking banned, dude. Like, you think I'm worth a 0 day? What are they gonna do? They're gonna steal my MetaMath? You know what? That's actually a good point. That guy's fucking banned. Don't, you know, why do you that's such a trolly question. Get out. If you were a subscriber, I'd tolerate it, but you're not. Like, in general, like asking questions about my setup and my keyboard, get the fuck out of my channel. Really, no one wants you here. You're not welcome. Unless you're a subscriber, then you're tolerated, but... if you're not a subscriber, you'll just be banned. It's an axiom. Oh, I see. But a provable statement has to have a proof. Well, that makes a lot of sense. I mean, this is a very sensible grammar. This is much more sensible than the Coq grammar. Wow, compressed proof? Oh, is that what that stuff was at like the end of... As if this language wasn't terse enough, they have... This is a compressed proof? Wait, who's asking to be banned? How do they verify that their prover works? Well, you can't, but you can just re-implement it a lot of times. They talk about this in the first chapter of the book, and they're pretty convincing. Proof. Uncompressed proof. Or compressed proof. Is that really what that stuff is? I mean, this is cool that you can just write this language so quickly. Well, okay. I should speak after we've written the language. I think we included any of this stuff, so I don't think we need it. Well, we definitely need to know variables, a math symbol, but we don't need to know a fucking constant math symbol. Variables, math symbol. Type code? So we use it. Type code is a constant. Oh, it's a constant that we've defined up here. I see. And that constant is a math symbol. Alright, great. Now to define the thingies. So doing a good job in the other grammar, don't I? Printable character. Deviate a little bit from it here. Okay, so we gotta define a math symbol. Should we just say oh, I mean, I guess math symbols can include obviously these guys. Label. Why don't they define printable character? Do we have comments in here? No, we don't have comments. We don't have to make that work. Okay, a label. L-char. Labels can include these things too. Comments do not nest. Define white space between tokens. How do you do that in the other grammar? These are fine. Token compressed proof block. Yeah. Sure. You know what? No, we should support them. A to Z, like Amazon. Using an undefined rule, non-terminal start. Well, the word's not there. I guess instead of database, maybe I have to call it start. Perfect. Alright, cool. Alright. Yeah, no, what we're doing is we're going to build a MetaMath verifier. Be back in a bit. to say that I've gained an appreciation for what metamath is, and that I was too harsh on it this morning. And I take back. I don't know. I mean, like, I'm excited that I think we're actually going to be able to write a verifier for metamath relatively quickly. Like, remember how much we spent in the first episode on the grammar for Twitchcock? We spent a ton of time. And we didn't really get anywhere because that language is so complex. I mean, this language may err on the side of simplicity, but like, they are self-aware. You know, like all keywords begin with a $sign character. This mundane monetary symbol is not ordinarily used in higher mathematics outside of grant proposals. So we've appropriated it to distinguish metamath keywords from ordinary mathematical symbols. It's an interesting, like, this is written by like OG hackers, right? The fact that they keep talking about ASCII. Yeah, pretty cool. All right, let's write this verifier. Like this, to be fair, their grammar is so much more readable. I think what you really want to do is, wait, who dodged? Oh, Grisvok gifted subs. Wow, that was nice. That was really nice. Mr. Tryharder, you're talking about Kameai in this channel? And Boja, you're talking about, what are you guys talking about? I feel like a lot of people should be banned. I just, who wants to, you know what? Grujvok, by gifting streams, congratulations, you're a moderator. Ban whoever the hell you want. You see, we believe in corruption on this stream, and money can buy influence. All right. So, constant statement, variable statement. I still don't really understand why a constant statement isn't a statement, but the grammar does make it clear that it's not. I've been coding in C++ 11. I really like it. I feel like this is kind of ugly code. It's really the same shit. Boilerplate, 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 boilerplate. Python's really not a good language for these kind of things. Okay, let's understand what a hypothesis statement is. Floating statement. Let's focus on one of these at a time. We have two hypothesis statements. They're floating statements. We do essential ones, but only inside the scope. I guess I don't really understand scope. Like, what's allowed inside of a scope? What if I take those out of the scope? Does this thing still compile? Oh, we should have it. I was actually using MetaMath. Was I build MetaMath? Yeah. Sorry for people wanting to run this on other computers. You gotta set up your directory structure like me. Does the scoping matter? No. Doesn't work. We need the scope. Alright, we'll kind of understand what this is at some point. So those are axioms. And those have labels. Wait, honestly, who's talking about keyboards? And Mr. Bankster, timeout, don't talk about drugs either. No drugs and no keyboards. We're trying to cultivate, I add everybody on LinkedIn. So basically when I post ads, more people will see them. It's my personal brand, bros. No, like, we're trying to cultivate a higher brow audience here. And if you don't want to be part of that higher brow audience, you can get banned. Sometimes we get some people in chat who are like really smart and like know things about type theory and category theory, Coq and MetaMath, and these people we welcome in chat. And some people come in and talk about keyboards and drugs, and they can, get out. No, we're not talking about simulation. What if you're not smart? I mean, you're not going to get banned for not talking. Maybe that's you've ever heard the saying, if you don't have anything nice to say, don't say it? Well, our saying will be, if you don't have anything smart to say, don't say it. Okay. We have a floating statement. That's the name. I mean, there has to be some better way to write this. You have a video of me smoking weed, Georgie boy. Get the fuck out of my channel. I smoke weed. There's nothing wrong with smoking weed. Comments like that, you will ban. All right. Variable type floating hypothesis. Constants are declared, variables are declared. We could declare a right parenthesis to be a variable. That sounds like a good troll. We're trying to understand floating statements. An F hypothesis tells MetaMath the kind or type of its variable. It is analogous to a variable declaration. Let's read the statement. Okay, so, oh, I guess it's like it's a type? Oh, those are types. As a type code is a constant. Okay, that makes sense. So it just says that, so one of these constants up here, WFF, is a type, and it's basically just typing the variables. Interesting. Okay. Should I make it a... is WY? Is there a way to... How do I drop into the debugger in Python? It's like PDB? This isn't really what I want. I want... Yeah, this is what I want. I don't understand this parser yet. So I can do like xx.pretty and it's that. xx.data is a floating statement. How do I like get the stuff out of this? I think it is just dict, right? So, like, tree object is not subscriptable. Like, do I just really? So, and I'm not really sure why it has a label. But alright, so like, is this really what you want me to do? There has to be some better way to do this. Here I don't actually need that. You just leave it in the type from the... TYC in constants, start var in variables, variable sub var subtype equals TYC. Perfect. Okay, we parsed the floating statement. Again, I'm not really sure why, but we'll figure it out later. Chat's real dumb this morning. It doesn't matter what editor you use. This is bike shedding. Look up bike shedding. Okay. Where are we next? Parsed floating statements. Do we have to parse essential statements? No, we gotta parse axioms next. No axiom? Indent a little more. No axiom. Just only for floating statements. Assert statement. Oh. Again. Alright, fine. I'll indulge the nested depths of this grammar crap. Okay, asserts can either be axiom or provable. No, this makes sense. Very sensible stuff. And that's where we'll write our proof parser in there. Oh, this. I blame Lark for this. Okay. So it looks like an axiom has a type. And then a bunch of math symbols. What's a math symbol again? Well, it can be anything. An active constant. Math symbol must be active. We'll discover it when we discuss. We gotta parse blocks too. We'll get there. We'll have to make this thing work scoped. Okay. Axioms have a type and then math symbols. Well, I guess I can actually just say things, I can just call it asserts, right? Because it doesn't matter if something's an axiom or a proof as long as I verify it. No, and it definitely is a dict because they have labels. So we have a label. Actually, this looks very similar. Cool. Alright, and then here we'll just say asserts sub-label equals. I mean, the floating statements, I'm not even sure why I really had to save. actually do the same thing for provable statements too. Just let's do that. Which should be fine. Yeah. My screen time is up 20% last week. Most of it probably in the Kindle app though, so that's fine. Grizvok, thanks for banning people. I'm sure they were all terrible. Kraken DMP, thanks for subscribing. Okay. So we don't actually check the proof. Is proof. Good. I mean, like, asserts and axioms and proofs are the same thing. Proofs are checkable and axioms are not, right? Theoretically, you could just make every proof an axiom, and then everything's just definitionally true. But, you know, that'd be dictatorship. And this is America. I don't know. I think a lot of people miss the point of the simulation talk. You know what? I know how I'm going to fix my terrible chat problem. Subscribe. Subscribers only. I feel like most of the subscribers say higher brow stuff. That's a good way to deal with, you know, what's your favorite Eminem album? I do want to make it clear also that subscribing doesn't guarantee you won't be banned. You still might. So for those just joining us, what we're doing is we're writing a verifier for MetaMath. This morning we were very upset at how complicated MetaMath was. No, at how, well, not complicated. I mean, the language is extremely simple, but expressing something in it is complicated, and this is usually how it works, right? Like, to learn the syntax of assembly language is very simple, and then to actually express anything in it is hard. So, what this is a grammar for MetaMath. If you guys want to play along at home, I'll just commit where I am. We haven't written any of the hard stuff yet. Overall, this has just been boilerplate. But I think we're about to get to the hard stuff. I mean, so right now I'm just assuming to do actually check the proof. We do have to understand still what they're doing about scoping, because the unparsed ones here are blocks. Let's understand, they probably talk about scoping. Scoping. Okay. So this E, we have to understand what E's are. Essential statements. I don't know why they just say math symbol. I mean, that could either be a variable or a constant. I probably do want to go back to when we had this in before. I do want to go back to that, and then so we actually have math symbols. Like, this is terrible code. I feel like coding in C++ 11 makes you a better programmer, and coding in MetaMath makes you a worse programmer. We're gonna let everyone talk again. You guys gotta behave. I think there's a 20. I think there's a 21. Okay. So floating and essential. put the tea aside for a little bit, and we're gonna get some water. You can't just drink tea all day. We'll stay up all night. I don't understand what these essential hypotheses are. I do understand what they mean about scoping, but I guess I don't understand why it didn't verify when I took away the scoping. Why wasn't this verified? Statement 2 requires 3 hypotheses. Why does that change state? Oh, I guess because I understand. Okay, so this is a prerequisite for this, and it goes away at the end of the scope block. But, okay. Basically, that's like a criteria. It's almost like a variable. Like it's almost like saying like int x in C. Sorry, that doesn't make that much sense. Good. Blocks are just lists of statements. Yeah. If data's block, then I can just say like for y in xx.children, and then y's are going to be statements. Are they statements? Yes, they're statements. Okay, so here I can just say parse statement y. Statement y dot children sub 1 0. I mean, yeah, that's good. Make the screen a little bigger. Why are you printing all this crap? Where's this prints? Alright, good. We're hitting the E's, right? Yeah, we're hitting the E's. Okay. So we have these essential statements here, and these are the ones that go away. These two go over here. This one, just copy it from here. It's MS. I don't know. I mean, this won't work, but yeah. Before an assertion can be referenced by a proof, I'm not sure why the labels of those matters. do it. So an essential statement has a type and then has MS. The math symbols. Not the best code I've written in my life, this parser. I mean, the fact that I have to write like children and I can't write, I don't know. I'm probably just using it wrong. We can look up Lark examples if we want. But yeah. Whenever we go to axiom statement, we need to bring SN with us. And because these only parse if they have yeah. Not really sure why those labels matter. What happens when you print a label. All right. We just need to verify the proof. All right. Like, you can follow the MIU thing. Shouldn't be too hard. I told you guys yesterday, read that book. People didn't do their homework. Okay, so what is a proof? A proof is just a set of labels. Or sometimes a question mark. I see. I'm not going to ask what the question marks do. We're just going to accept that sometimes there are question marks. It's terrible that they're labels because they're not math symbols. Why are these labels and not... Oh, I guess because they're axioms. Okay. That makes sense. Assert S in asserts. Boom. All right. I'm getting somewhere. Now we just have to verify the proof. So proofs are just strings of asserts, which are labels, which are either axioms or provable statements, or floating statements, or essential statements. But I don't really know why those go in the same namespace, as those don't actually seem to be used in proofs, but maybe they are, and just not this kind of proof. All right, so I guess we just go through, so each of those asserts is an axiom. And we just need to make sure they're all correct. So if it doesn't have any essential hypotheses, then it doesn't matter. But if it has essential hypotheses, we're going to have to consume things from the stack. I guess even if it has variables, we're going to have to consume things from the stack. Is that right? Like, this is a variable, and this is a constant. Right? I guess, like, there's an implicit for all in that. Okay. I mean, it's just this is an interesting language to wrap your head around, right? So, like, WFF is their equivalent of a type, but M, I, and U are also constants. See, like, in most languages, those are different things, right? In most languages, you have... This is just weird to wrap your head around, man. But it is cool. Like fundamentally what it's saying is that you can do all of math with just this dumb symbolic manipulation. I really, man, this is really hacker. It's like the symbols only have meaning that you give to them. The language isn't putting the meaning on the symbols, hence the meta math. All right, I get what you guys are trying to do. Very cool, very cool. All right, let's see if we can write the thing which can manipulate the symbols. So I feel like, yeah, so let's start with a simpler theorem to prove. Theorem 1 is very complex. I'm gonna have to support comments because I'm gonna comment it out. Who wants to add comment support? How do I do it in the last thing? This kind of crap. Work. I'm having trouble with this last tip. Put comment anywhere but there. It is that symbol. No terminal defined. You know what? We'll just leave this one in. and we'll start with the simple theorem. Now, we should make comments work. See how they define it in their EBNF. Oh, they define it in white space. But that's effectively what I did with this. Okay. Fixed. Okay, let's start with a very simple theorem. Is P1, I don't exactly understand what turnstile means, but if all I want to define is Mi, then that should just be AX, because it's an axiom with no essential hypotheses. Yeah, so wait, that's just an axiom, right? So turnstile Mi is an axiom. It's literally AX. And I guess what we want to assert at the end of the proof is that kind of the symbols that we've pushed onto the stack are the correct ones. Can't verify that proof. We have to verify proof with MS as the target. So kind of like after we're done with this recursive Polis notation processing, we want to check to see if what we got was this string. I don't know why type. I don't really know why the type has to be different. And I guess it has to be a constant according to the grammar. Yeah, so we have a type code here, and a type code is a constant. Which I guess, should we assert that? Yeah, let's assert that here. WFF. If that's a constant, I don't understand. What? Oh man, really? Okay, cool. Good, look, we already fixed a bug. So this is the axiom being used, and this is the output. So they clearly match. Axioms have types as well. call this one trivial because it's an axiom. And we'll call this proof less trivial. I want to show MII, and we can do that by this rule. Rule 2 is the one where we double the thing after the 2. Yeah, so we're just doubling, returning. We start with the axiom MII, we push the variable I, and then, okay, good. Much more complicated. Collapse or distraction. So what we're doing is we're writing a MetaMath verifier. So I wrote this little thing here this morning in MetaMath. It's the MIU system. It's just the example. If you run check, you can confirm that it works. Oh, well, it's just because theorem 1 is commented out right now. But we're verifying all the proofs. In real MetaMath. Now we're writing our own verifier of MetaMath. Like, I mean, I don't know. Maybe there's tooling out there that makes this language usable. Because having to write theorems in this reverse Polish notation is insane. This is for machines, not for people. But, like, are there IDEs? Discussions of pi. So what this has to do, confirm stack is this. These things are going to push symbols onto the stack. This first pushes that it's type well-formed formula and has no math symbols. That's not exactly right. Why is that an axiom? What would happen if I remove the we here? Why I requires a hypothesis. So what's a hypothesis again? Either a floating statement or an essential statement. Sometimes you hear the planes. You know who David A. Wheeler is? There's a Vim plugin for MetaMath. I mean, yes, there might be a Vim. I'm sure there's a Vim plugin that's going to do syntax highlighting, and we can get it. But syntax highlighting is not the problem with this language. Let's just put it in the Vim folder. files. MMA also A. Does this work? Okay. This doesn't make it better. This language didn't need syntax highlighting, though it is interesting that it does really distinguish these math symbols from these math symbols, which are good. So I guess like at the end, finally the type has to be correct. And we push it. This is confusing me. Oh, I guess the X that's consumed is just... This doesn't consume anything. This consumes... No, see, you think that it's turnstile, but that's the whole point of this language. It's not actually turnstile. Turnstile is like a type. It's just arbitrary. Like I could replace it with foo and it would do the same thing. It's meta math. You get it, guys? Okay. So I'm not sure what order things are popped off the stack. I guess the fact that there's two X's here, you don't actually have to duplicate it. Oh, I guess it just like binds. Okay. I could see how this is written. I mean, this might all just be spelled out in the manual. I don't know. I usually find it's like a better way to learn things by just like trying to reverse engineer it. Approved is a sequence of statement labels. Yeah. The construction must ultimately result in this sequence. Otherwise, MetaMath will consider the proof incorrect and will notify you that you're an idiot. All right. We're going to prove such a reference its corresponding statement. Association with any assertion is a set of hypotheses that are active with respect to that assertion. Some are mandatory and the others are optional. I'm not exactly sure because all the labels that we're using, I believe, are previous hypotheses. Yeah, we're not using any label of an active hypothesis. You may be familiar with RPN if you've used older Hewlett-Packard or similar handheld calculators. I think we're gonna make some guac for lunch. Like guac? MetaMath looks up the symbol WS and determines that it's a hypothesis. So it pushes the symbol sequence of statement WS onto the stack. All right, so we're going to do a little something, I think. This isn't really right. Fine, I guess. At each stack location, you have a type and you have a set of symbols. So for this, we're going to push onto the stack. Oh, this isn't too bad. Stack. Can I do push and pop in a Python array? What's the best way to do this? Yeah. Append. Pop. Okay, cool. I didn't know you could pop from an array. So we'll say stack.append a sub type. Just do a tuple here. Type and ms. Alright, now of course it's really not that easy. You know what? Let's just try it out. Wow, C++ been messing with my brain, man. It seems like every slot on the stack has a type and has then a string, right? So this is the type of this string. All right, then what we want to say here is O equals stack dot pop assert O produced O expected tie ms. All right, good. Look, so it verified the proof for less trivial. Verified the proof for trivial. Now let's verify the proof for less trivial. something prettier? This has no attribute pretty. Get rid of that. Token has no attribute data. And I'll make it say the word token. Pretty. Token has no attribute pretty. What attributes do tokens have? How do we just get like the code? You know, maybe. It's not gonna work either. Whatever. Doesn't matter. It prints the word token. We're not thrilled about that, but it's okay. All right. So what we shouldn't be pushing onto the stack is variables. S is a variable, so no, never mind. Variables do end up on the stack. I feel like this is supposed to consume this, though. I'm not sure how I'm supposed to know that that's supposed to consume that. Produced MXX and it expected MII. Now, I really don't want it to say this token thing anymore. Tokens inherit from string. Yeah, part of the problem is it's doing repr. Can I actually do string here? It would work okay. Produced this MI, expected, see? All right, and now we see what we're doing wrong here. Let's just fix up push here, use LP. Pushed that, popped that, produced that for that. Pushed that, pushed that, pushed that. Now we have to verify that. Making progress, bros. You guys ever hear the expression? It's a Tim Leary expression. The PC was the LSD of the 90s. That's how I feel about AI now. And not like lame AI. Not every time you hear AI used as a buzzword, that's not what I mean. What I mean is like AI is going to enable trippy stuff, assuming we don't make it lame. You know, it's really cool the way the computing revolution worked out, the way like personal computers came before IBM mainframes. 'Cause computing could look so different. Computers could be controlled by a small group of people, which in a way you almost do see today. Do you really own your iPhone? Well, yeah, if you use Checkmate. But the fact that it leaked out, Turing computable things leaked out into the, like powerful Turing machines leaked out into the population in a way. And, you know, if they could have put them back in the box, I'm sure they would have. I wonder if AI is similar. Like, these concepts, there's never been a field that's more open and expressing all these things. And I know, like, you think these things, oh, this isn't AI. You know, AI is using neural networks or stuff like that. But it's all getting at the same point, which is program search. If we could figure out how to efficiently search over Turing complete spaces, I'm not sure if that's supposed to push onto the stack like that, or that's supposed to bind to the variable. Well, there's only supposed to be... So we're not even doing the right number of pushes and pops. What's the manual say? MetaMath encounters an assertion label. It associates the mandatory hypothesis of the... Okay, Okay, maybe I don't really understand what's a mandatory hypothesis and a only used if relevant. Question. Why do I need these statements? What uses them? Should be a comment. Why doesn't it light up like a comment? Looking at this parser. The variable y doesn't appear in an active f statement. So you basically have to type all your variables. Oh, a keyword must be preceded by white space. Funny. Yeah. Huh. After proof 4, the RPN stack contains 3 entries. All variables in A and P statements must appear at least in one such hypothesis. Okay, so whatever it is, this typing is very important. These are being used even though they're not being referred to by name. I'm not exactly sure why. I mean, I guess that has to be x. And x is, we are asserting that x is the type. Is that? I mean, saying x is type WFF, does that mean we take WFF and we put it down here? What are we programming? We're writing a verifier for MetaMath. We need a little more T. T. T just makes you think. Yeah, so I guess this here is being substituted in for x. All right, let's try this algorithm. ms equals a sub ms for v in ms. If v in variables, print v. Bindings. If v in bindings, ms to append ms through in variables, v not in bindings, and I'm gonna append bindings of v. Okay. Stack.pop pt v nms. And we want to be a little bit careful here. We want to say plus equals bindings sub v, assert v sub variable sub v sub type equals vt, confirm variable, let's just get a comment, bindings equals vnms. Is that right? That is the wrong type. That's not right. Oh, man. Okay. Why aren't the variables being bound? Okay, I guess bindings can go anywhere. I think we have to verify. I mean, is this not? Isn't actually verifying anything, but this is right. Am I? Why is that am I? Why is this an I? If that there, oh, no, this isn't right. ENMS is the, Okay, I'm doing this wrong. What we want to do is we want to zip E sub ms with, okay, so first we want to assert E sub type equals ET. Confirm, we don't need a comment. Okay, so the type should type check. Now we check the other things. If n1 in variables if n1 not bindings say, yeah, so it's bindings variables, and we can say assert binding sub v. No. Oh. Okay, so if it's not a variable, assert v equals n2. If it is a variable, we can look it up in bindings. No, so this isn't exactly right. What am I doing wrong? Must verify. Ah, okay. I mean, that's basically the same thing that we're doing down here. Verify this is that. Ah, no, this isn't right. I want to push this. This is a different amount. No, this is right. Why can't I do NMS here? Something is broken. Oh. Okay. Woo! I think we got it. Perfect. Verify less trivial. Let's uncomment that and see if that proof verifies. No. Huh. Do we have to read these the other way? I mean, it looks like the wrong thing is getting bound to X and the wrong thing is getting bound to the same problem here. Here where we bind variables. Just guessing here. We shouldn't do that. This should be an obvious enough part of the language. Well, at least this verifier is failing. Let's pop that and then Which fields have a lot of scopes, cyber or machine learning? You ready for a no scope? Ban. That's no scope right there. Okay. Must verify. We gotta do this back. I mean, this is right. We could bind everything first. Oh, wait. But is this somewhere else? I don't understand how this verified before I added in. You see the problem? It's not. Yeah, I'm doing this at the wrong. You don't even want to assert v equals n2. You want to build out the. Yeah. Okay, okay. We can refactor this in a minute, but let me just get this right first. So we'll put nms here, and instead of asserting v equals n2, say nms dot append v, nms dot append binding sub v. Atom dot plus equals binding sub v, even better. Just basically just an exact copy of this crap down here. Let's just. I don't even need EMS here. Let's just put bind x. Let's just say bind ms. Equals bind ms. So we actually do this in reverse. Turn nms that. Okay, nms equals bind that. Now I can say nms equals bind this. And then we want to assert enms equals that. Bind. Okay, getting closer. Just add one more proof here. Even less trivial. This using a little 2 here to duplicate it, so see, does even less trivial verify? Even less trivial verifies. Okay. That was a stupid one. Let's just see why they're different. We're already asserting the type. Okay. So something's going wrong. Probably up here. 'Cause that's, I'm sure, not what I wrote. Oh. Okay, there's some subtlety here. I think this is it. And then how do I... Whatever. Problem is we were flipping the... There's a one-liner for that. But I don't remember it. Boom! All right. So you saw the problem there? I don't know if anyone's actually following, but the problem there was it was flipping the thing at the, it wasn't flipping at the symbol level. It was flipping at the individual symbol level, not like the meta symbol level. MetaMath. So there we go. Cool. Flipping at the meta level. All right. So we wrote a verifier that can verify theorem 1. There's still a part of the language we don't understand. So the dream is we should be able to say verify.py, and we should be able to run it on the real examples from MetaMath. We'll start with piano. Okay, well, I'm gonna have to fix the grammar a little bit. Math symbols can include plus, can include equals, can include less than, cannot include $, so that's a bug. Oh, did we not parse D's? What's a D? Put some D's on this bitch. It is D's. That doesn't seem right according to the grammar. All right, so you see we're verifying now. This verifies our small example that we wrote, but we're trying to verify something real now. Like if we do MetaMath. We can verify the proofs. So it opens scope, and then like that doesn't seem right according to that definition. Variable, variable, variable. Oh, star. Don't put a plus where you should put a star. Great. All right, we're not... I don't know why I didn't verify anything. I don't know what this joint statement even is. Are there no proofs in this? Well, this is actually cool. This is much more readable than the other stuff. Yo, you think we can parse set.mm? Oh. Well, math symbols include left parentheses. And they probably include right parentheses too. Yo, but I gotta say, this parser is not fast. QL? Is QL real? Hall? Is Hall real? Do they prove anything? Yeah, they prove a few things. Looks like we're gonna have to get scoping really correct. Good God. Wow. Colon can be a math symbol too, despite it. Commas can be math symbols. Backslashes can be math symbols. Okay, this is probably not a good way to do this. Chokes can be math symbols, both chokes. I mean, it's just char. It should just be any char. Slashy. The twiddle. At some point, we're going to stop doing this and realize that this isn't a good use of time, but that point isn't right now. Oh, we need exclamation points still. Oh, question marks, definitely question marks. Don't forget about question marks. Oh, at signs. Yes, we need at signs. Oh. Now we're up to the problem. Assert S in asserts. Assertioner. All right, let's copy that other trivial example. They gave in the manual. Because there might be something. I feel like there's something I still don't understand here. Like, the thing that's missing from my understanding right now is why the F statements and the E statements have names. Actually, I suspect that's exactly the problem right now. my lack of understanding of, here we go. Okay, so just copy and paste this crap. Let's call it simple.mm. Yeah, so it's the same problem. If we understand why this one doesn't work, maybe we'll understand why Hall doesn't work. And then did we write we wrote a verifier in less lines than them. But what, oh man, it's so tempting to say that Terry Davis line, best programmer in the world, man, best programmer in the world. It's catchy. All right. Yeah, it's using these things, which we didn't. When we define an axiom, use that. We validate the essentials, but I don't understand. Like, why is this being referred to here? Let's try to just first understand what this is trying to prove. So it introduces a bunch of symbols. I think like it just exists to validate the type. What does that push on the stack? Just pushes that on the stack. So it's effectively the same thing as an axiom? And because an axiom just, well, no, an axiom would try to bind the variables, and I don't think we're trying to bind them here. MetaMath looks up the variable. Yeah, here we go. Let's say if S in asserts. Hypos. Or do we put them in the same place as essentials? Oh, I guess they're really the same. I'm a little bit confused at the difference between the two. Variable type or logical. Floating means only used if relevant, and essential means always. I see, okay. So we can just put it in hypos. Same as this. Hypos. And we'll just say ms equals var. Yeah, so we have to push the hypothesis on the stack. This actually just might be just this. Push A sub NMs. Oh, they're not NMs, they're just NS. Okay. Now, to be fair, we're not actually track hypos to. I think that we also want to include these in hypos. By the way, so I understand that this says it's verifying the proof. It's not verifying the counterfactual. We're not verifying that we couldn't put invalid proofs in here and it would still verify them as correct, right? I could remove every assert from this code and it would still pass. But yeah, all right, let's make the goal trying to get it to verify like MetaMaths Hall. And then maybe it can even verify set, we'll see. Pop from empty list. I didn't do scoping correctly at all. Oh. We forgot a check. C label not found. Isn't C a variable? Bound variables, term variables. It's a variable. It's not a label. What does that even mean? How can you just have a variable there? Each label in the proof hypotheses labels may reference both the mandatory and the optional hypotheses, but can you just stick a variable there? That's what's confusing. C is supposed to be a label according to that, and it's not a label. It's supposed to be a label according to the grammar? Yeah. So you just put C there. This is a scam. Why is there a C there? Why are there variables and constants in my proof? The scope shouldn't matter. I sort of see what we might have did wrong. We're only adding, yeah. So what if we had more essential statements? Like, But it still doesn't make sense. I mean, like we have an essential statement here. And in a way, this essential statement should apply to this proof context. But I guess I don't understand this at all. Like, how is that a proof? Even with the Is it possible it's defined later on? And you're just supposed to like parse it all first and then run the proofs? I don't even know what D statements are supposed to be. The D statement. Disjoint variable restriction. Forbids the substitution of one variable with another. By the way, this shouldn't be here. This should go like that. Their grammar is starting to make a lot of sense. Still not up to disjoint statements, but I feel like we can waste time by doing scoping correctly. But I feel like, guys, first, we gotta make some lunch. We gotta make some lunch. I'm hungry. I'm gonna make some guacamole real quick. And I'll be right back. And then I'm gonna finish that up. Let's just write lunch in big letters on the OBS. Lunch. Lunch. Big lunch. You guys can watch me make lunch. Alright. Someone's got to clean this kitchen. This is getting disgusting. Alright. Let's get a bowl. I'll grab bowls. We can wash out this bowl. This kitchen has turned kind of into savagery. This bowl's probably pretty clean. This bowl looks clean. Look at the smell of that. Alright, we got avocado. Mash it in there. Should take all the ingredients out of the refrigerator first. Seems like it would be more efficient. Small onion and a lime. We need a lime. And 2 hot peppers. So aside from the avocado, which we already put in, these are our guacamole ingredients. Nice fresh guacamole. Chips. Let's see. We got guacamole, guys. It's just like coating, it's the same.
And
axioms. So basically, no. So consts become inactive. Asserts remain. Hypotheses. Disjoint variable restriction. So they both have to be variables. It can be as many as you want to. All those are disjoint. Assert v scope variables. V equals v dot children, so 0. Okay. Each variable is a previously declared variable. Simple version of this statement. It says something about bindings, and I think it's a property of the variables. know where to stick it at least. Well, I know how to parse it. So what we can say is that scope variables sub v sub disjoint AV we just have to check the disjoint condition when we do substitutions. No, we can actually try this. If disjoint in scope.variables v. I think I'm doing this right. You just have to confirm that all the ones that's disjoint with aren't in the list. Okay, this one still doesn't make sense. The only thing that I can think is that we have to parse the whole thing before we verify any proofs. Oh my god. Floor's clean, bros. Muscle Mario, does that little icon mean you're a subscriber? Because for all this shit you're talking, you better be a subscriber. Alright, now you're a subscriber. Alright, now you can talk shit. That's the rule. Okay. What if we don't actually verify any proofs? Because MetaMask doesn't seem to. MetaMask doesn't seem to verify the proofs in order. Proof. No, we're out of guac, you guys. We're out of guac. This is terrible. We already ate 2 apples and guac. And that's most of the food we have in this house. Oh, I know what we're gonna do. We're gonna make pasta. Lunch part 2. Pasta really takes a long time to make, and you gotta be super patient. This is what I've learned. Guys, if you saw the kitchen right now, it's unbelievably disgusting. We've been living like savage all week. The good news is, you see, the thing is, you have to verify the proofs in scope. This might work. Oh, yo, real talk, you gotta nest the scopes, but that's fine. It's easy to do now. Good thing we wrote proper scope. xx.data equals scope. Just do this. That's right, isn't it? do that. Oh, block. Put scope there, it wouldn't work. Yeah. Okay, well, it still complains about the same thing, but we're getting closer to being correct, I believe. I'm still baffled as to how that's supposed to work. Does setmm parse? Oh, we need ampersands. This is just basically every character in the world. Yo, we're making Rochettis, guys. We got Rochettis. Salt in that water. I'm not putting salt in the water. I'm not going to taste salty. I don't like that. Damn. Seems like a good amount of pastas. Oh, we're gonna run into the bowl problem again. What? Left brace. So you're gonna be asking about right brace. We're doing this again. I can't believe we're doing this again. Carrot. But actually, this is super slow because it has to load in all of this crap. QL? Maybe QL works. How big's QL? Does their MIU work? Their MIU works. Does demo 0 work? Ooh, demo 0 doesn't work. Sweet. No, it's like, I don't want you to know what keyboard I have. It's a secret. Actually, if you're asking that question, I just want you to be vamped. This doesn't matter, guys. Some of the best times of my life was when I was traveling with nothing. Being a good programmer isn't about what keyboard you have or what editor you use or any of that stuff. That's stupid. It's how you identify script kiddies. And script kiddies get banned. Print, hello sailor, I'm sorry you don't like my content. Hey George, can I work with you? On what? You want to work on this? You submit a pull request. Let's see, has anyone submitted a pull request yet? If there's pull requests, you can work with me, but that's the way to work with me. Can I work for you? For some reason I think managing you, if you're asking me that question, for some reason I think managing you would be more effort than, no pull requests. This shows something I don't understand. No, I mean, yes, typo fixes are low quality pull requests. Submit. Oh, how long ago did I put the pasta in, guys? You know, I gotta hand it to whoever wrote the other MetaMaths. This stuff's so fast. Okay. What if I just take this assertion out? Does it pass otherwise? No, it doesn't. So there is some other bug. I feel like this shouldn't be allowed. I feel like you can't bind T to T. Can you bind T to T? That seems like cheating. Bind T to T plus 0. This seems like the problem. You can't bind t to t plus 0. That makes no sense. Then what are we doing wrong? That's like ending up with that happening. Am I getting stack corruption somehow? Just a random guess. That's a problem. Yeah. The problem is the order of these matters. And if they're in a different order, yeah. There's two binding essential statements. Sertraline. What is this? Oh, some shit to your SSRI. Selgaline, that's an interesting drug. I think my pasta's ready. I didn't time it or anything, so I don't really know, but I feel like it's ready. Let's eat a pasta and see if it's ready. Oh, it's hot. No, we'll cook a little more. We have to find a colander anyway. Where'd it go? It's the string wrap. No, but where's the stringer? Ah, somebody put the stringer away. Guac bowl's pretty clean. Used it recently. That's pretty good. Pastas. Or chetties. Okay, we figured out the problem. How do SNs get ordered? You know, it's either one way or the other, right? So let's just change SN to be a list. And then it's the value there. We just do that. And then we change this to append, so the label doesn't matter. And we can do this, move that here, move that here. No. Don't do that. Still has issue. Okay. I still don't like how it's binding T to... I mean, that just doesn't seem right. Just unbind it? No. I don't know if you can. Might not be relevant here. frame. Hmm. We make a copy of variables in the scope. Yeah, we do. So it should work okay. No two F statements may contain the same variable. We can actually code that in. Any F statement must occur before an E statement. Yeah, that's implicitly true. Yeah, I've seen a lot of bannable stuff in here. You know what? We're just gonna have to do this. I'm gonna go back. Okay. Let's try this experiment. Following sequence of statements is not a frame because R I don't know anything about that. That's not right. I just found it interesting. It was the same thing as there, which is failing. If P, so okay, yeah. I mean, this is just cool. You see what the example is, right? Like we didn't prove anything yet, but we can try to prove things. Here, the chat becomes so much more pleasant when we make it subscribers only. You're just, like I always say, subscribers are just better people. Bro, your terminal doesn't matter. Let go of all that bullshit. Who cares? I could write this code on an Apple II. You want to put images inline? I was watching a Temple OS tutorial last night. It supports this. Okay. Oh, you know what? No. But we can. So this is using the modus ponens rule. This should be P, which is right. I think. Okay. Let's just print this out and see what's wrong. The variable Okay. Here's where it could be backwards. What if we first pop those and then bind? You see what? You see what could be happening, right? So bind is calling stack pop 2, but SN is calling stack pop. When there's one SN, this isn't a problem, but when there's multiple SNs, it's a problem. Well, it's a different problem, at least. Now we just might have these backwards. No. We're guessing. we'll try letting everybody talk again. No, please don't. We actually do have a name for that rule too. We can put it in there. Min. Must verify. Oh, see, okay, it is backwards. All right, so we're trying to verify this is that and that is that. So it's backwards. So we'll just do that backwards. Okay, that's right now. That's right. I don't think I want to iterate backwards here. I think I do want to bind. I mean, that's the wrong type even. This is just not verifying correctly now. Which just means that we have some bindings wrong, probably. I still hate this. Like, maybe it is correct. I don't know. actually P. No. We know P is... No, that can't be right. Because we know P is WFF. So when we're binding P, it has to be a formula. It can't be a turnstile. So we're popping this well-formed formula, and then we're binding P to it there. Oh. So, see, this isn't right. This should be binding Q, not P. Because that's Q. All right, notice how this matches this. Why is this saying bind P? All right, now we can at least verify it. Working on Madge. But if we print EMS, it should be back. Huh. Oh. Who sees what I did? Who sees what I did? So stupid. There you go. All right. Verifies the demo. Verify simple. Verify MIU. Verify simple 2. I'm pretty happy with it. We didn't deal correctly with disjoint variables. But I don't know. We dealt with scope correctly. I'm pretty happy with that. We dealt with things that take 2 parameters pretty nicely. I'm happy with that. And really, we've gained an appreciation for MetaMath, which was the whole point of this activity to begin with. Yeah, I agree. Print hello sailor. We should have used a more strongly typed language than Python. A lot of those bugs were due to Python's shit scoping, and really, how is that even in scope? That bug there? Like, how was E even in scope when I was just using it down here? The problem is, the bug was I had this. Like, I don't even understand how E is still in scope. We gotta late bind those variables. We're never gonna program in Java. Java's the worst language ever. No, and look, they know how bad Java is. Little Kotlin kind of cleaned it up. The world gets better. But yeah. Happy Sunday, guys. I'm happy to have you all with me. Today started out on such a raging note. Calm down. We wrote a verifier. And I mean, it still makes no sense. Right? Like, I'm not saying, I'm not defending MetaMath's I'm not saying that this is a sensible way to ever write it. Who wrote that? Did they write this by hand? Like, Norman McGill, if you ever watch this, did you write this proof by hand? That's my question for you. Or do you have some like sick IDE which lets you like, you know, manipulate the stuff nicely? But like, this stuff's all new. There used to be something called MMJ2. Actually looks like it's still kind of developed. It abbreviates the following detailed proof. The essential form of the proof. Yeah, I mean, this looks better, but can I write things like that? A little check. I'm sure I didn't fix it all. If anyone understands why I got that error, I'd be interested. You tried MMJ2 today. It's really inconvenient. Yeah, why am I not surprised? MetaMath, on the contrary, you may only enter the theorem's names. You may not enter the formulas directly. I really do believe that Norman McGill wrote these proofs by hand. Oh yeah, why don't we check out this guy's webpage on GeoCities? Well, turns out GeoCities is down, guys. The concept here is so cool. Like, remember how the point of this probably actually won't even be the last Twitch Cock stream, but I guess we'll kind of come full circle here. So the point of Twitch Cock was to re-implement Cock in Python, and this turned out to not even get past Cock's typing system, which was very confusing and we didn't understand. On the other hand, you know, we could should I write this, like, I could write this same proof in Coq in no time. What is this theorem? It proves that T equals T? So we instead of Twitch Coq is growing. You know what? Let's update the README to say what we actually did. Just kidding. Coq is too complex. I was about to say. We implemented. We implemented MetaMath instead. Update README. You like my documentation? Yo, you know how many people would die for 42 GitHub stars, man? And this shit got 42 GitHub stars. This is trash. This is a trash project, and I should be embarrassed by it. I mean, it is kind of a working MetaMath verifier. I don't understand why it doesn't work on hall.mm. Like, I don't understand how to parse that by hand based on everything I've read. So I'm sure if I casually read more about MetaMath, I'll understand at one point. But at least, like, the things that are parsable by hand are now parsable by my Python. So I'm happy about that. Should we just try? All right. Let's see if we can get MMJ2 to work, and see if it's usable. I heard from one Twitchy that it wasn't usable. All right. Let's see. Quick start. Double click mm2 jar mac mmj2.command. Wait. User 1? I just, this isn't supposed to. Oh, do I have to like edit this or something? Well, we can't ink the GC. No more inking of GCs. Okay. Command line path invalid. Oh. I mean... Does that fix it? Oh. Well, okay. That's nice. What do these commands do? Well, let's just give it more memory. Actually, what if I don't parse? Oh, maybe run parms? Yeah, here we go. What if, let's just edit run parms to load MIU instead. Oh, you know what it might be? Why my thing didn't work? I might have forgotten okay. Okay, I mean, someone somewhere maybe got this to work. I'm trying to load the example and telling it to check the proof, and this doesn't work. Looping, kill it. I'm scared of GMFF. Watch out, don't cast your swings. Okay, well, that clearly is not what's being used by a lot of people. Unless your username happens to be user1. Wait, the errors went away. But checking the proof still doesn't work. Forward get proof? Backwards get proof? I mean, someone may have used this at one point. It does look like there's still commits. Why does Siri think I said her name? Steel art. This isn't really math. This is like just weird stuff. But yeah, you know, Coq seems like it was written by programmers. This seems like it was written by someone who really loves. MetaMath is basically just find replace in your editor a lot. Yeah, it's not like a language you can code in, but it really does get you to rethink. Like, if this is all math is, just these sort of symbol manipulations. There might be a way to use MetaMath in interactive mode, actually, that I didn't try. Oh, the thing that I thought that I might have not implemented is includes, but there's no includes in here. I still don't understand why this doesn't work. To anybody who explains this to me well in an issue, I'll be impressed. But I think that's mostly the stream for today. We wrote MetaMask verifier. It's pretty good. Any last questions? Chat got better too. Excuse muscle Mario. Bye bye.